All right, guys, welcome back. So today I want to talk to you guys about something called the average atomic mass, and this has to do with stoichiometry. So let's first talk about stoichiometry first. So what's stoichiometry about? It's about counting how many elements, how many atoms, how many molecules you have. It's about counting. So first of all, we have to have define a few terms. So the first thing that's very important is atomic mass. So what is atomic mass? So it's the mass of the atom in a unit called AMU, which stands for atomic mass unit. And this is the number that on your element periodic table, we have, let's say this is your periodic table, and over here you have different elements. So within each one of these blocks, you are having elements. And if we zoom in there, what you're going to have is first the symbol. In the middle will be the symbol of the element. Let's say in this case, C will stand for carbon. And on top of it, you will have a number. And will be a whole number, meaning it will be like, it won't be something with decimals. So 1.1 won't be there, it will only be 1, 2, 3, 4, 5, 6. And this number is the atomic number. And this indicates how many protons you have in your element. And below it, you have another number that will be in decimals. And this is the atomic mass. And actually, this will be the average atomic mass, which is the thing we care about. So average atomic mass. So what is the unit of this number over here? Well, it's not in gram, and it's also not in kilogram, right? Because it doesn't have a specific weight. So everything is relative. So for example, for hydrogen, you're gonna have one proton here. That's what is how many protons determine which element this is. And you have 1 point something, let's say 1.01. So relative to a uh, atomic mass unit, which is have a definition that we don't really have to care about, but I'll just give let you know. So the AMU, so average atomic mass unit, equals the mass equals to exactly 1/12 of the mass of one carbon 12 atom. This is the definition of it. So that means a hydrogen atom in this case will be 1.01 times the mass of 1/12 of the mass of a C12 atom, right? And so that's why later on we'll talk about Avogadro number and how you convert from here going to grams. So that's why um, when you have 1 mole of something, the mass of it will actually be 12.01 grams. So that's not a coincidence. That's based on how things are defined. But let's talk about what's the average atomic mass. So the problem is, why is it in this weird form like 12.01, or sometimes you can see 12.02, etc. Why is not a whole number just 12, right? Why is that? And the reason is because there are things called isotopes. And these are the things that all have our carbon. So carbon, carbon, carbon. You may have six. All of them have six neutrons, six protons. That's what make them carbon. But they have different number of protons. You might have six. You might have seven. You might have eight. And protons and neutrons also have weight. So the weight of the carbon with 7 neutrons will be greater than the one with 6. The one with 8 neutrons will weight more than the one that has 7 neutrons. So what will be the average weight of these? And that correspond to the different abundances in nature. So for example, in nature, you have 90. So in nature, on average, 98.9% of all the carbons have six neutrons, and 1.1% have 7 neutrons, and 0% have 8 neutrons. So how would you calculate the mass of it? And so so sometimes calculating this might be confusing. So I just want to simplify this problem a little bit so we can better understand. Let's say we're talking about apples here, right? And there are two kinds of apples. The one that's in this color, and the other kind are in this color. All right, that's the difference. And they have different weight. Let's say this one weight 1 pound, and this kind of weight 2 pounds. And I want to know, and I know that, so let's say there are a lot of them, and I know that 40% of them are this kind of pink apple, and 60% are the orange apple. And I want to know what is average weight of all the apples. So this is exactly the same question I'm asking here. Instead of apples, you have different kind of carbons, different kind of atoms. So this one is C6, and then you have six neutrons, and this one is C6, and you have 7 neutrons, right? Just different apples, different carbons, and they have different abundances. In this case, 98.9% and 1.1%. In this case, just 46. It's just easy numbers and easier things to understand. So let's go back to our apple problem first. So what's the average weight of our apple? Well, if we calculate it, right? So let's assume I have 100 apples. That means I have 40 of 1 pound and 60 of 2 pounds, right? So the average weight will be 40 times 1 lbs plus, so that's the weight of 1 pound apple in total, plus the total weight of 2 pound apple in total. So 2 times 40, so that's 1 pound times 40 of them. Sorry, I already got 1 pound here. So that's 40 of 1 pound, and I also have 60 of 2 pounds. So that's the total weight over. So I wanted, because I'm looking for the average, over my 100 apples, right? So what this is going to give you is, so let's don't look at the result yet, because I want to simplify this to the percentage. So what is percentage? Percentage is just, if it's 100%, it's a 40%, it's just 40 over 100. That's 40%, right? Which is exactly what we have here. So it's 40 over 100 times 1 lbs plus 60 over 100 times 2 lbs. And that's why you can simplify this directly by the percentage. So this will be 40% times 1 lbs plus 60% times 2 lbs, right? See how I go from here. So 40 over 100 over here. This number is just 40%. And this number is just 60%. That's why you can directly bring it here. So if you calculate this, if this doesn't make sense to you, you can always refer back to this equation here. So what does this value gives you? So this value gives you, all right, this value gives you 40 plus 120. So this 40 pounds in total, 120 pounds in total over 100. So that's 160 pounds over 100, so that gives you 1.6 lbs per apple. So that will be the average weight. So referring back to our atom problem, it's exactly the same thing. So average atomic mass, what should I do? So if I go to this step, so step 2, let's say, I just bring the percentage, so 98.9%, just like the 40% we have for apple here, times molecular weight. Let's say it's molecular weight for the one with 6 neutrons will be 12 AMU plus, now I want to go for the second one. The second part is for the one with 7 neutrons will be 1.1% time its molecular weight. Let's say it's 13.00335 AMU. And if I calculate this with my calculator, I get 12.01 AMU. And that's why this number over here in this box here says 12.01. And this is actually how we calculate that's what all of them, all these numbers are being calculated in each atom box. So let's do a different example over here. So let's do iron. So iron, the symbol will be, so this will be our example question. So in your exam, they will always ask you a very simple calculation problem. They will tell you first which element it is. In this case, will be iron, Fe. And they will tell you, okay, so this element have several isotopes. So this Fe 54, Fe 56, Fe 57, and Fe 58. You don't have to care about these numbers. You just have to know they're different. They have different atomic weights. So, and they will tell you for each one of them the atomic mass, which will be, we just learned in the unit of AMU, average molecular unit, average mass unit. So for 54, it'll be 53.93612, 55.93439, 56.935396, and 57.933278. I know lots of this 12 numbers is really bothering, but this is just how accurate science should get. And secondly, they will tell you a abundance. So this will be in percentage, right? So this will be 5.8, 91.72, 2.2, and 0.28. So what you want to do is just like the apple problem we did before. You just time the percentage with the corresponding atomic mass, and you plus them together, which gives you the average atomic mass. All right, so let's do this example. So it doesn't matter how many of them there are. If there's 10 of them, you just do more of the plus of the times over here. All right, so let's do this example. So the average weight for Fe will be, so 5.8%. Remember, it's percentage. It's not, you don't time 5.8. You don't do 5.8 times 53.93612. You do 5.8%, right? So 5.8 does not equal to 5.8 over 100. So this is the second part is 5.8%. So you plus all of them together, 55 times 55.93439 times 91.72% plus 56.935396 times 2.2% plus 57.933278 times 0.28%. And if I calculate this and I take the average of them, I get somewhere around 55.85 AMU. And if you go to your atomic chart for Fe, which has 26 protons, 55.85 is actually the relative atomic mass that's being pointed out here. So, first exam, there will always be some problem like this. I hope this is helping you. And if you like this video, please subscribe.